We should practice sometimes like which part you want to do. Hold on to decide which one.
So it's Dylan is just sort of two, items, yeah. Yeah. Oh, wait, no, just stay.
So I have been confused. I have two calendars in the room, one by the computer and one on the other side of the board, and they are off by a day. So I'm confused. Today is supposed to be homework review, which according to that sheet over there is supposed to be Thursday. Anyway, so tomorrow you have an exit card on doing some kind of use substitution stuff. It's on Delta Math. There's a homework tonight that is on Delta Math that is not optional and will prepare you for how questions will look and how they expect the answers to look for the exit card, okay? And some of the kinds of things that you need to be able to do is basic integration. Like these don't need any heavy hitting use substitution. You could do them without. So Felipe, this first one, how does that integrate?
Integrate to 3 and then x minus 5. Oh, the Gale bars.
Jail bars, absolute value. And then chain rule, divide by the derivative of the stuff inside, which was a 1, so it doesn't matter. Okay, whose derivative is positive sine, negative cosine? Okay, and it was of 7x, so when I did the derivative, I would have multiplied by the derivative of the stuff inside, but I'm integrating, so I divide by the derivative of the stuff inside. The last one's tricky. Recommendations, suggestions, ideas, Alana?
Like, I made it into e to the power of minus 5x, so then I just had it as e to the power of minus 5x divided by minus 5.
Oh, I should just cut. So she had a great idea and said, I made it e to the negative 5x, because e to the stuff, integral or derivative is e to the stuff, but we're integrating, so she divided by the derivative of stuff, and I'm going to take that negative and her negative 5 and the negative that was there already, make it a plus, and then I'm forgetting one more thing.
Plus C.
Plus C. Daniel's on it. Cool. Integration. And this bottom one is checking. One, to see that you still understand the relationship of acceleration, position, and velocity, and to have the perseverance of integrating a couple of times to get an answer. What is the relationship of acceleration to position?
It's a double derivative.
Double derivative. Okay, so I need to integrate acceleration to get velocity, and then I need to integrate velocity to get position. Okay, what is the integral of 32 dt?
32x.
32t plus c. Okay, and then I gave you some information and I said the velocity at time 2, which I should have been clear. this is gravity. And I'm making gravity positive, which means the forces are going down. But the velocity at time 2 is 10. So 32 times 2. My initial velocity was negative 54. Okay, so velocity equation is 32t minus 54. How do I get position given velocity? The integral of that is going to be my position at any given time, okay? So raise the power, divide by the new power. This is why in pre-cal, gravity was oddly always in there as negative 16t squared. But you knew gravity was 32. Why? I had to integrate. Minus 54t plus some new c value. That's the equation of position. How do I find the exact place? Well, going to the initial value for position, -5, and then plugging in the 2. So the equation in the end, 16t squared minus 54t plus 39. Okay, questions? Were there questions on any of the homework? Any of these guys, in particular 13, which was on last night's homework? Okay, then I ask about 13. How do we do that? Constantine?
Well, I made u equal to ln x.
Okay, so my suggestion to you guys was look for a function where you see its derivative, look for the thing in the bottom of the fraction, look for the thing being raised to a power, the thing under the square root. In this case, there's my function, and it's hard to see the derivatives there. Because often we just look at the denominator and then it's like, oh, there's a couple of dudes down there. All right, well, translating, ln x is u, and then dx over x is du. Sophia, how do I deal with these guys?
You plug them into ln x.
Okay, so when x equals e, what is u?
1.
1. Okay. And when x equals 8 or 6?
Natural log of 6.
Okay, gross. Francesca, how does that integrate?
So then you, well, then you just, like,
I gotta integrate. How does it integrate?
oh, it's just, sorry, ln u, and then you evaluate from 1 to ln 6, so it's,
It's natural log of 6, which is awkward. Natural log of 1? 0? Zip. So that's your answer. Yeah?
Natural log of 6.
Yeah. And that is not natural log squared, by the way.
So that's natural log of 6 times natural log of 6.
It's like sine of 0 isn't sine squared. This one? Go ahead if you have a suggestion. on how we might tackle this one?
Oh, yeah. It's just tangent 3x.
Okay, and either you guys memorize these, which I told you not to do because I was gonna show you in this one, now that we've done U substitution. How can I rewrite tangent split into different trig functions? Sine over cosine. Ooh. They are each other's derivatives. Which one, there's only one that's the right one to choose. Which one is the U value? The one in the denominator. Okay. So integrating, changing things out, 1 over u sine 3x, u dx is negative 1/3 du. There were no bounds on it, so natural log of the u value plus c. And for those of you who have it in your notes, I did not give you the formula this way. I told you the integral of tangent. Oh, goodness. Told you the integral of tangent should have been that. Did I do something wrong? Did I have you memorize or write down the wrong thing?
The C value.
Good try, but not the c value.
Is it the negative can go into the ln?
Negative on this guy is 1 over cosine 3x, which is secant. And then, like, the derivative of tangent is secant squared. The integral of tangent is natural log of secant. Like, I like that tangent and secant are friends and they stay that way. This is not wrong. And if you get that, and cool. But this fits the pattern to remember things. Any other issues with any of these guys? Okay. So I want to do a little bit of what we were supposed to do tomorrow so that there's lots of time for the exit card, and when we're done, you can start the delta math. So what we were supposed to do tomorrow is this. We'll write this one down. This one is a doozy. It needs some space. So see if you can figure it out. Like, first thing it says, separate variables.
You were not kind.
You know, it's a goal. Okay, separating the variables. This whole integration business, these things were, like, this was the height, this was the width. Often in algebra, it's like, you pick a side, move all the numbers to one side, all the letters to the other, and it didn't matter. This time it matters. the width is dx, not 1 over dx. So I need x's to be with dx and y's to be with dy. Okay, I see all these yucky y's. They need to move. How do they move to the other side? Do I subtract them? Divide? Okay. It's a horrible mess. But now I have dy, and I have x dx. I will do the hard one. X squared over 2 plus c. The other side, well, now there's some business. I have no idea. So let's think about rewriting stuff, maybe changing like the way it looks at us.
Like, I don't know if this will help me, instead of cosine squared, they secant squared.
Okay, he says, I don't know if this will help, but he says cosine squared is secant squared.
That's tangent.
Oh, and I can integrate secant squared. It's tangent, so that was helpful.
That's what I thought.
Mhm.
That's not.
Okay,
Stupid.
but I kind of think I need some u substitution because it's not secant squared x or secant squared y. It's secant squared of square root of y. Yeah.
Can you say that u equals root y and then substitute it twice?
Substituting it twice. Okay, first multiply by the power, lower the power, and 2 du equals 1 over root y dy. So, still haven't solved this yet.
Oh, so you don't actually need the second, because the second one goes away. Oh, I see.
Yeah.
That's.
So secant squared of u, and then dy over root y is 2 du. Okay, that is progress. Okay, can you guys finish it from there? And by finishing, it says, solve for y in the form of y equals f of x.
C's cancel out.
Are they the same c?
No, probably. No, they're not. Probably not, that's what I meant to say.
Alright. So integrating secant squared becomes tangent, and I put the u value back in. Alright, you guys always ask, plus c, shouldn't this one also have a plus c? So that's the unknown junk from the x side, this is the unknown junk from the y side. Can I just be efficient and swoop all of the unknown crap to the same place? And still call it, hey, some unknown value? Yeah, so, and why do I always put it with the x? Because usually they're going to tell me, find y. So I put all the unknown crap on the same side that we normally want it for. And Andy, I think this is gonna make you cranky more than other people. I gotta solve for y, so I'm gonna divide by 2. I didn't divide by 2 there,
It's constant.
because it's an unknown constant. Okay, so I have half of the stuff I didn't know about. It's still stuff I didn't know about. Okay, uncomfortable. Tan inverse.
Wait, you don't have to do c over 2 because the c is just an unknown value.
Yep, and on the next example, I'm gonna change that. And hopefully we will see the difference in y. don't know, whatever that is gross.
A lovely number.
Yeah.
Sorry, I don't really understand how the CY and the CX just like turn into C.
Okay. So you have to guess how many cards I'm holding. I have some in my left hand and some in my right hand. Does it matter how many are in left or in the right? Or am I just, so I'm gonna all in one place guess. Whether you're guessing, oh, you had 3 over here and just, I asked how many all together. So I swept the unknowns all to one side. Okay, so this one is horrendous. This is a former question off of the free response. So, Sam, don't scoff. They high chance that they will put a 1 over cosine squared somewhere, and you need to think about it and be like, I know who you are secant squared, and I know whose derivative is secant squared, it's tangent, and I will integrate you. Ha. So, the square root business, like things that create, when doing the derivative, they create something in the denominator, y'all hate them. And because you hate them, they like to give them to you. So square roots, natural log, and then the opposite way, well, putting this down here, you have to take an extra understanding step to go backwards. All right. This is the other piece of initial value problems. I'm actually giving you an initial value now. And the thing that's scary about these, it's often on the AP exam on a free response question, and the rubric always says 0 out of 5 if they do not separate. Stinkers. How do we separate that?
Oh, okay.
Just showing you things you know from the past. If I'm doing x to the 5 over x to the third, well, that's x to the 5 times x to the negative 3. Oh, when they're on the same level, that's 5 minus 3, so it becomes 2. Okay, so how do we go backwards? How do I pull e to the x minus y apart?
Is it e to the x times e to the negative
Is it e to the x times e to the negative y? Yes, it is.
yeah. Y. Oh, it's, what he said.
Well, you can write that as e to x over e to the y, then, right?
Yeah, because
Okay.
So it's easier to see like the cross multiplication.
Yeah.
And Ben says, couldn't we write it like this? You sure can. And then he said, doing the cross multiply is so much easier. You saved them a headache, Sam, or Ben. The two of you, 3 letters, ends in an M or an N, I just, yeah. Soccer, frisbee, you know, sport. The other class, we divided by this, and so this is one of those, it took them a long time. They were like, I don't know how to integrate that, I don't know. And someone's like, hey, move it up. E to this stuff is, it was so much easier that way. Okay. Sophia, what's the integral of e to the y?
E to the y times the derivative of y.
Which, because we have that dy on there, is going to be just 1.
Okay.
And it would, yeah. So it's e to the y equals e to the x plus c.
Because you've already like done like the combining of the c's.
Yep.
Okay.
Moved them all to the same unknown spot.
And then you can do ln of both sides, natural log of both sides.
Okay. So I need to solve for y. And he says do natural log on both sides. All right. ask because I think half of you will do this wrong. When you do ln, you do to the entire group, the whole entire side. If you were multiplying by 2, you would have had to multiply each of these blue guys by 2. So over here, natural log of e to the y is y. This one, natural log of e to the x and that plus c is swooped in there. But they want us to find the particular solution, the unique solution, or the exact solution, the one on that slope field that goes through this coordinate. Okay, well, plug the y value in for y, the x value in for x. Natural log of 2 equals natural log of, what's e to the 0? 1. What is the c value then?
1.
1.
Oh, facts.
So y equals ln e to the x plus 1. All right. I'm going to go back here to the stuff in blue, and I'm going to plug in the equation there, the coordinate. E to the y value equals e to the 0 plus c. This is 2. C equals 1. And then I got to go back to where I chose to plug the value in. Once I plug things in, so Andy, right here, that I'm plugging in stuff. Now if I doubled both sides, c is fixed. I have to double the c as well. But e to the y equals e to the x plus 1. Do natural log of both sides and I still get the same answer. So you can plug in at any step. And once you plug in that initial value, it freezes. Okay, yeah.
Wait, how did you get from ln 2 to y equals ln e to the x plus 1? Like, how did you? 'Cause
Sorry.
it was 1. Oh, because ln 2. Oh, okay, sorry. I didn't see that.
2 had to equal 1 plus c.
Yeah.
I was running out of space, so
Okay.
I cheated and, yeah.
Are you saying we should, like, plug it in earlier for C, to
Um,
find C, or wait?
So we will do more of these, and it will kind of depend on the question, which one is more complicated to do. All right, so that's all I wanted to tell you. You guys can start documenting.